Welcome to this tutorial on how to find derivatives using the chain rule. Let's look at a problem. Y equals 2x plus 4 squared. And let's say that we want to find the derivative of this function. Well, without using the chain rule, what we'd have to do is we'd have to expand the function out first. So we'd get y equals 4x squared plus 16x plus 16. And then find the derivative of this function here. So that's y equals 8x plus 16. No big problem with that one. But what if it wasn't to the power of 2? What if it was to the power of, let's say, 16? Having to expand this bracket out 16 times is quite time consuming. So what we can use is we can use the chain rule to help make this process a little bit easier. I'm going to explain how to use the chain rule through this example. Let's just assume that we're going to let u equal 2x plus 4. That means that our y value now is just y equals u to the power of 16. Pretty easy. But we want to find out what dy by dx is, not what dy by du is. So dy by dx is going to be, using the chain rule, dy by du times du by dx. And as you can see, that the du's will actually cancel out, leaving us with dy by dx. So let's finish this problem off now. Dy by du, so the derivative of y with respect to u, is going to be 16u to the power of 15 times, and let's look at our u function now, du by dx, the derivative of u with respect to x is just 2. So du by dx is 2. So this problem is 32. U is 2x plus 4, 2x plus 4 to the power of 15. And that's a much quicker way to find the derivative rather than expanding that term out 16 times. So this process of substitution and linking up one derivative with another derivative in a chain-like manner is what we call the chain rule. So to find dy by dx, I'm linking up dy by du and du by dx to give us the derivative we are looking for. When do we use the chain rule? We generally use the chain rule when it looks like we have one function, 2x plus 4, inside another function, u to the power of 16. That's how we know when to use the chain rule. Let's look at another example where we can use the chain rule. If we have y equals e to the power of 4x squared plus 2x minus 5, we want to find the derivative of y with respect to x. As you can see, we have an exponential function and a quadratic function. So we have a function inside a function. Again, using the chain rule to help us out, let u equal 4x squared plus 2x minus 5. Then we can write y as y equals e to the power of u. This is a much simpler problem to solve. And again, using the chain rule, what we'll do is to find dy by dx, that is the derivative of y with respect to x, we'll find the derivative of y with respect to u, and then we'll times that by the derivative of u with respect to x. Again, we're linking these two up using our chain rule. And what's going to happen again is that these du's will cancel out and we'll have dy by dx. So the derivative of e to the power of u with respect to u is just e to the power of u times the derivative of u with respect to x. The derivative of u with respect to x is going to equal 8x plus 2. So we'll just times this whole thing by 8x plus 2. Now, because we're looking for dy by dx, we need to change this u back into our x terms, where u equaled 4x squared plus 2x minus 5. So that's going to be, I'm just going to move the 8x plus 2 to the front, e to the power of 4x squared plus 2x minus 5. What about using the chain rule with trig functions? Well, we can also use that. What if we have y equals sine of x squared minus 3x plus 4? Again, what we've got is we've got a quadratic inside of a trigonometric function. So let u equal x squared minus 3x plus 4. Then we can write this y is the sine of u. So to find dy by dx, we can use the chain rule again. Dy by dx is going to be dy by du times du by dx. Dy by du is just going to be cos of u, and du by dx is going to be 2x minus 3. So we'll times this whole cos of u by 2x minus 3. And then this leaves us with, I'm going to bring the 2x minus 3 to the front, cos of, and again u is x squared, minus 3x plus 4. Now we can link up as many variables as we want using the chain rule. For example, if I have y equals sine cubed of 2x plus 5, let u equal 2x plus 5. Then our y variable is going to be equal to, and I'm just going to put it in brackets for now, it'll make sense in a second, sine of u to the power of 3, because that's our sine cubed of u, where u is 2x to the power of 5. Now what we're going to do is we're going to let v equal sine of u. So now our y function is going to be v to the power of 3. So as you can see there, we had a linear function inside a trig function inside a polynomial. And again, let's use the chain rule to solve this one. So dy by dx is going to equal, we have to start with the most recent function that we had. So it's going to be dy by dv times dv by du times du by dx. And as you can see, the dv's are going to cancel out and the du's are going to cancel out, leaving us with dy by dx, which is what we want. So we can use the chain rule, linking up as many terms as we want to find the desired derivative. Dy by dv is going to be 3v squared. dv by du, so dv by du is going to be cos of u, and du by dx is going to be 2. So dy by dv is 3v squared, dv by du is cos of u, and du by dx is 2. 3 times 2 is 6. We're going to have 6v squared, where v is sine of u. So that's going to be 6 sine squared of u times cos of u. So cos of u is cos of 2x plus 5, because u is 2x plus 5. Now what we need to do is we need to write this u in terms of x as well. So to do that, we're going to go equals 6 sine squared, u is 2x plus 5, times cos of 2x plus 5.